Let's start with Module 1. We'll do an introduction, we'll talk about frameworks, as well as management practices. For context, my name is Alfonso Berumen. I have over 15 years of experience in consulting, providing data-driven economic, fiscal, and local support to various organizations in a wide range of industries. I've also taught graduate level courses in data science and data analytics since 2018. And my current role is as an academic affiliate for Libra Analytics, an analytics consulting firm. I am also full-time faculty at Pepperdine University as a practitioner faculty of decision sciences, which is basically just the field of using quantitative analysis for decision making. So what was the reason why this course was created? Well, I had obviously I have experience as a practitioner, and I've noticed in practice that there is a gap of sorts. This is further demonstrated by, it's actually a term that McKinsey developed, the analytics translator. And the idea is that there's a need for those that can actually translate data to valuable recommendations and valuable strategy. So you can see there, I have a statement: we need professionals who understand the whole process and the value that can be realized by an organization. The analytics translator is actually defined as someone who's not necessarily a data architect nor a data engineer. They may not even be a dedicated analytics professional, and they may not possess deep technical expertise in, let's say, coding or programming or modeling. So McKinsey actually estimates that there's going to be a significant demand for this type of individual that possesses this skill set or is trained to be able to do this. But the basic skills are domain knowledge or expertise of a certain industry, sector, field, even an organization. Technical fluency, so working knowledge of statistics, including how to assess the accuracy of, for example, predictive models, project management skills, as well as an entrepreneurial spirit. So there's an article put forth by several authors who contributed to this article titled "You Don't Have to Be a Data Scientist to Fill This Must-Have Analytics Role." So where does the analytics translator fit? Well, they have 5 sort of steps as, say, part of an analytics project. The first one is identifying, prioritizing business use cases, in which the role is to work with business unit leaders to identify and prioritize problems that analytics is suited to solve. Collect and prepare data. So there the translator helps identify the business data needed to produce the most useful insights. Step 3, building the analytics engine. The translator ensures the solution solves the business problem in the most efficient and interpretable form. Step 4, validating, deriving business implications. There the translator synthesizes these insights into easy to understand, actionable recommendations that business users can easily extract and execute on. And step 5, implementing the solution and executing on insights. There the translator would drive adoption amongst the business users. So I saw a gap in practice, and additionally I saw a gap in business education. So with business education, there's actually been growing use of machine learning and artificial intelligence in the field of business analytics. So sort of where the graduates end up or would like to end up. There are many organizations practicing business analytics, as well as the potential operations someone may be asked to perform, right? So as in graduate education, we've had to actually adapt quite a bit. So many programs are actually embracing this sort of experiential learning, consulting-based approach, where universities actually partner with real businesses to give them feedback on real problems. So there's benefits on both sides, both for those partner organizations and also the students themselves. To take a step back, what we're referring to is this idea of data-driven decision making. So as opposed to just using maybe gut or intuition, decision makers in organizations are using data and information to assist in decision making. So we do have a lot of data. One estimate as of 2024 is that there's actually 402.74 million terabytes of data that gets created each day. So what is actually data-driven decision making consist of? So you can review that six-step process compiled by IBM, but they basically have this, this outline process of first defining objectives or business objectives, identifying, preparing, and collecting data, organizing and exploring data, conducting data analysis, drawing conclusions, and then implementing solutions and evaluating those solutions. Further, and from a more practical standpoint, we're basically relying less on gut instinct and instead on data-based analytics. And that's happening more and more that we see actually in practice and industry. But we've also been witnessing a data revolution, as these authors point out. Firms actually gather extremely detailed data and then propagate knowledge to their consumers, suppliers, partners, and competitors. And it's actually been shown and studied, shown, to a better way to put it, that companies that have better employed or sort of better adopted data-driven decision-making are more productive and more profitable. Let's go a little bit further and think about what's business analytics in practice or in management practice. Well, when I was studying or doing research for my doctoral degree, I sort of gravitated to this resource-based view. It's a good way to sort of conceptualize how data analytics can actually lead to or translate to value if done effectively. So there's this idea of developing a capability, and a number of researchers have found and shown and demonstrated that there's basically three different types of resources that a firm organization would need to assemble or acquire to develop a capability. For simplicity, capability is basically a way that a firm can outsmart competitors or develop a competitive advantage or sort of extract more value based on being able to leverage that capability. So there's actually three different resources. Tangible resources, which is data. Pretty obvious, we need data. Technology, for example, we might need business intelligence software or programming software. Basic resources, including funding. Human resources, which would include technical skills, so technical staff and the right training. Additionally, on the human side, managerial skills, which includes analytics acumen to be able to understand how analytics can be used to benefit the organization, or how results can be used to benefit the organization. Then finally, intangible resources. So having a data-driven culture, or as I mentioned, with respect to data-driven decision-making, is relying on data for decision-making as opposed to gut or instinct. And finally, organizational learning, or the propensity of an organization to want to obtain new knowledge and adapt. Well, it turns out that there's these three resources that could lead to developing a capability around analytics or data analytics, but there's no global recipe, right? It's not like, I need two staff, one manager, this amount of data. There's really no global recipe to develop a capability. And the analogy that can be used is with beer, right? Beer has some basic ingredients, water, barley, hops, and yeast. But there's a number of different beers out there, right? By country, region, different styles, and they can all be unique. However, ultimately, these basic ingredients, similar to data analytics capabilities, can be assembled to produce beer, right? In the previous slide, we looked at those three resource types and noticed that those three resource types could comprise or could compose a data analytics capability. So similarly, firms may orchestrate or leverage resources in different ways, but in the end, they all produce a capability of some kind. So suppose we've developed capability. So how do we think about the value that we get from that and what it impacts in terms of outcomes, right? So, we're often thinking of, okay, well, KPIs like profit, revenue, and so on. But in fact, it can be very difficult for firms, organizations to measure the value, at least from a tangible or objective standpoint. So you can actually see here that, and again, this is as part of what I had discovered is there's actually different strategic foci that firms may have, right? Some firms may want to focus on operational excellence or efficiency and value for money. Others may want to focus on customer needs and customers, or basically inciting customers to pay for a premium service through personalization and customization. So we can call that customer intimacy. And then finally, there's also the possibility that firms will sort of more emphasize product leadership, right? So product development, innovation that could then lend to the development of new products. So there's different strategic focuses based on the firm or based on the organization and their objectives. Additionally, there's also different business processes that could be impacted or enhanced. And again, enhancement through data analytics. So there's supplier relations, customer relations, product and service enhancement, production operations, and also sales and marketing support listed there. And you could largely sort of think of those as different divisions or operating areas of a firm, right? So depending on the strategic focus and also the critical business processes that are tied to those strategic focuses or foci, the value from analytics can actually be achieved in different areas. So I'm going to go ahead and transition to an example of that. And that example is actually through pizza, right? I just talked about beer, so I'm going to talk about pizza now. So think about in pizza, right? Domino's is a big company, and they've actually been partnering with Microsoft for a while, right, to enhance the ordering process using personalization and simplifying that as well. And they actually are using Azure AI to help facilitate that. Alternatively, there's Mod Pizza, right? That's where you get a personalized or customized pizza, and they actually are uh, they actually partnered with a firm to use their analytics tools to improve customer preferences, right, or improve understanding of customer preferences or their knowledge of customer preferences. So again, actually, this firm also partners with or actually touts that they user integrate with Snowflake. It's actually cloud-based software that helps facilitate analytics. So why do I use these two examples? Well, there's big Domino's and then smaller Mod Pizza. Domino's may say that they're really focused on all three of those strategic foci. Well, what they're really trying to achieve here is efficiency, right? Operational excellence. Whereas Mod Pizza, they're a lot more customer focused. That may allow them to charge a premium for that pizza, and that would fall under customer intimacy, right? So what I'm saying here is that both of these firms are using and leveraging analytics, using very sophisticated technologies to do so. But where they hope to get value and where they're going to measure value is in very different process areas. All right. So let's take a step back. What's the basic idea with business analytics? Well, we need some tools, right? So we talked about these ingredients, including the human side, but from a tangible perspective, we do need some tools and technology. So we need to be able to collect data, right? That might come from software systems, that might come from electronic surveys. We need a place to store and manage it. So we're talking a data warehouse of some kind. We need a place to obviously access it as well, right? So that would be where that would take place, right? Maybe a data warehouse or a data lake. We need data analysis tools, so software like Python, R, SQL language, right, to query data. So we need data analysis tools. We also need data visualization tools, right? Data visualization tools like Tableau or Microsoft Power BI would allow us to visualize data as well. Finally, we need collaboration and communication tools. So that would be software such as even Slack, right? That allow us to sort of communicate, collaborate with others. And I'll actually mention as well that Google allows for a lot of collaboration. In fact, I can even share a coding file with someone else, and they can collaborate and also contribute code. So we've sort of talked about many of the introductory concepts, how business analytics is used in practice, and sort of some of the ways to conceptualize that in a more layman context. But lastly, I'll sort of talk about CRISP-DM, right? CRISP-DM is the cross-industry standard process for data mining. And the idea is that this sort of general process can apply to data mining projects across a number of industries and sectors. So the phases are business understanding, which basically is the stage for which you develop a business problem or use case or business question. Data understanding. So from there, you understand what data you have, what data would you need. Also evaluating the cost of collecting or needing to collect or access more or different data as it relates to your business problem or question. From there, you may actually go back and forth. So it actually is an iterative process or iterative steps that you would go through. But once you have your data and you're ready to start analyzing that data, there is going to be some prep, right? You might have to merge data from different sources or collate data. You may even have to create variables or create new columns or even filter that data. Once you're comfortable with that phase, then you would move forward and go into modeling. So you develop your, say, statistical models. Again, this process may be iterative, right? You may go back and forth between modeling and that data prep or refining that data prep. Once you have your model finalized, then you evaluate. So evaluating the accuracy, whether or not it actually addresses the business question or business problem that you originally developed. From there, you go into deployment, right? So that's where you make it live. It's making, say, live predictions or live estimates. And again, this process is iterative. And the important thing I want to point out is that not every data project would require all these steps, right? For example, there may be some business questions that don't even require a statistical model or let's just say a sophisticated machine learning model or advanced analytics, right? It may actually be solved by doing some descriptive analytics or diagnostic analytics, which would be more business intelligence type work. All right. So these are just some basic terms. So you have data analytics, right? The process of collecting, analyzing, interpreting data sets to find patterns, trends, and correlations. Business intelligence, which I just mentioned or just noted, combines business analytics, data mining, data visualization, data tools, and infrastructure, as well as best practices to help firms make more data-driven decisions. Business analytics, right, it's a broad term, but it's actually a subset of business intelligence, an infrastructure that facilitates the collecting, storing, and analyzing of data from business operations. In fact, business analytics contributes to this effort by turning your company's raw data into useful information for things like measuring performance, identifying trends, predicting outcomes, and more. So advanced analytics, I'll save you on the time for reading, but advanced analytics is basically includes more advanced or more sophisticated techniques. That would include data, text mining, machine learning, pattern matching, forecasting, visualization, semantic analysis, sentiment analysis, network and cluster analysis, also multivariate statistics, graph analysis, simulation, complex event processing, and neural networks. So basically more advanced techniques or more advanced techniques that can be applied to analyze data. And then finally, artificial intelligence, right? That's a big buzzword, but we can see that Tableau defines that as a branch of computer science dedicated to creating computers and programs that can replicate human thinking. I would say largely right now what we conceptualize as AI is improving our efficiency, right, or assisting our thinking and ability to think. And then finally, decision intelligence. So DI is actually a practical discipline that advances decision making by explicitly understanding and engineering how decisions are made and how outcomes are evaluated, managed and improved via feedback. So stop there, right? That's a good introduction to concepts in business analytics, both in practice and with some terminology in hand